This is the lecture video for section 7.5. Here we're going to talking about algebraic defined vectors and the dot product, which is the other multiplication for vectors. So this is the first video. Here I'm going to talking about the magnitude and the distance of a vector, and then I will talking about horizontal and the vertical component for any vector, and then last we're going to talking about the vector operation. We talked about vector before. Vector is made with magnitude and the directions, and normally we can using a picture to graph the vector. Here I have the graph for the vector u, where the initial point lies on the origin, and then I actually write it on the xy plane. So since I have the vector u is on xy plane, then for the terminal point, I can have a coordinate on xy plane. I'm going to call it a and b, a comma b. That means on the x direction is going to be a, and then on the y direction is going to be b. Now, the angle between, that is the theta. So in general speaking, the length of the u is the magnitude, and then the angle theta is the direction. Since here we're using the a comma b for the terminal point, and then the initial point is actually lies on the origin, we can actually label the vector u in terms of a and b. So we can say u is equal to a comma b. However, since u is a vector, so we cannot use the round parentheses, we're going to using the pointing parentheses. So that means u is a vector. Then since we have the value ab, then I can actually find the magnitude of my vector u by using the distance formula or Pythagorean theorem. So the magnitude of u is going to be equal to square root of a squared plus b squared. And since once I extending the a and b's, I actually create a right triangle, then theta, which is the direction, I can find it by using tangent inverse of b over a, because tangent of theta equals to b over a. Now we can looking at one example using the magnitude formula and then to find the direction angle. So example 1 says find the magnitude and direction angle for u equals to 3, -2. A vector u equal to 3, -2. So to find the magnitude, we can using the formula the magnitude of u equals to the square root of a squared plus b squared. Here a is 3 and b is -2. So we got square root of 13. And that is the magnitude of the vector u. Now we can find the direction angle. So direction angle says our tangent of theta equals to b over a. So that means theta equals to tangent inverse of b over a, which is -2 over 3. And when we're finding it, theta is approximately equals to -33.7 degrees. But we normally prefer to say angle in a positive direction. So the angle theta is actually 360 minus 33.7, which is 326.3 degrees. And those two are the answers for the direction angle and the magnitude. Why we end up with a -33.7 is because if you're going to plug in 3 or plot 3, -2 on the xy plane, you're actually going to end up vector u is sitting on the 4th quadrant. So that's why your theta from the inverse function, tangent inverse, you got the negative theta, which is only talking about the negative from negative power 2 to 0 direction. Second part we're going to talk about here is the horizontal and vertical component for any vector. So I'm still using the same vector u sitting on the regular position, and then has the terminal point a comma b. That means x equals to a, y equals to b, and then the direction angle of theta. However, since we have the a and b, we can see we can actually have two components for a vector u. The first one is talking about horizontally. So a is also talking about the horizontal component for any vector. And b is talking about the vertical direction. So b is the vertical component for any vector. Sometimes we do not know the measure for a and b. We probably know the magnitude of the vector u and then the angle of theta. Then we can also come with a second formula. Is just continue from this side. Vector u can write it into a vector a comma b, or I can also write it in the way that the magnitude of u times cosine of theta, comma the magnitude of the u times sine of theta, which coming from our trigonometry definition. Now we can looking at the example. So example 2 says I'm talking about a vector v. So v has a magnitude of 25 and a direction angle of 41.7. We want to find the horizontal and vertical component. So to do it, if I'm just going to erase them, if I'm just going to say now this is my v is going to be 41.7, and then what I'm looking for are the a and the b. So to find it, I can use the formula that the magnitude of u times cosine of theta is a, magnitude of u times sine of theta equals to b. So a will equals to the magnitude of the v times cosine of theta, which is 25 multiplied by cosine of 41.7, which is approximately 18.7. b is going to be the magnitude of v times sine of theta, which is 25 times sine of 41.7, and we got approximately 16.6. So the vector v is going to be 18.7 comma 16.6. In 18.7, that's the horizontal component, and then 16.6 is the vertical component. In the last section, we're talking about we can adding two vectors, but we're mainly talking about geometric ways how to adding two vectors. But in general speaking, geometric way is not very practical. So here we're going to talking about vector operations using both horizontal and vertical component. So this is my original picture with the vector v, and then the v has the horizontal and vertical component a and b. Now I added a second vector v has the horizontal and vertical component c comma d. So what I can say is I have a vector u which is a comma b, and then I have a vector v which is c comma d. So when we're adding two vectors, here I'm not going to say u and v's, I'm more talking about the a, b, and c, d's. So when I try to adding the two vector a, b and the vector c, d, then I'm simply adding the vertical components together and then the horizontal components together. So that means I can just adding the a and c and made with a new vertical complement, and then b plus d to have the new horizontal complement. If I want to multiply a vector by a scalar, so here I'm using k as a symbol for a scalar, and then I'm going to multiply to the vector ab, then I simply multiply the k to both a and b. So I got k times a, comma k times d as my b as my new vector. If I want to find the negative, so for example, u is vector a comma b, then the negative vector, negative u, will just equal to negative a comma negative b. So it is exactly the same length, but going to the opposite direction. Then lastly, when we try to talking about subtractions, then I can just subtract a and c and b and d. Now let's look at an example. So example 3 says u is a vector negative 2 comma 1 and v is a vector 4 comma 3, and we want to find the following. A is u plus v, b is negative 2 times u, and then c is 3 times u minus 2v. So to do it, I can just using the u plus v, which is negative 2 plus 4 comma 1 plus 3, which is 2 comma 4, and that's the vector u plus v. Second one, negative 2 times u. So I can use negative 2 times u is negative 2 comma 1. So negative 2 times negative 2 comma negative 2 times 1. So we got 4 comma negative 2, and that is negative 2u. And then the last one, 3u minus 2v. So 3 times negative 2 comma 1 minus 2 times 4 comma 3. So we got negative 6 comma 3 minus 8 comma 6. Subtracting them, we got negative 6 minus 8, 3 minus 6, so negative 14 comma negative 3. Lastly, we want to talk about is a special vector. So unit vector, as the name suggested, will have a magnitude equals to 1. And that is the definition for a unit vector, that is magnitude equal to 1. So magnitude equal to 1 doesn't mean that, for example, the vector has 1 comma 1. 1 comma 1 will have a magnitude of 1 square plus 1 square, which is square root of 2, which is not 1. So for this situation, unit vectors, we have to calculate it. We cannot really see it from geometric wise or just number wise horizontal vertical component to see if I have a unit vector or not. We have to checking it by using the magnitude formula.